Yeah. Are you able to hear me?
Yes,
Hmm?
sir.
How many people have joined?
So
Huh?
they're joining now, sir.
Yeah, yeah, yeah. So today we'll start revising, huh? And hopefully, like I was ill, if you might not be knowing, I was in the hospital for 10 to 15 days and then
Yes, sir.
at home also. Now I'm feeling good. As I promised you, now this thing has been extended, your exams also. So I'll be making separate notes also for you people, and let's revise from which topic you want revision. Like from the starting, we'll revise for this 14 days. Hmm? Some of you have missed also, no? Shall we revise from the beginning?
Yes, sir.
So we'll revise from the beginning. Okay. So uh, this is uh, this is control and distributed things. Okay. So the, yeah. Are you able to see the this thing board? Huh?
Yes, sir.
Okay. So we'll start with basics of the field. So in this particular basics, uh, when we are seeing these basics, so most of the times the students are getting confused. Okay, where is the confusion? After checking the book, is confusion is there. Somebody else has joined. Shall I put? Did you put the message in the group?
Yes, I put the message.
No, in the main group. Okay, confusion is in applying KVL or KCL. Now there are some steps. Okay, so there are some steps how to apply. Okay, so what we'll be doing is that, suppose if I make a circuit something like this, hmm, it has one more resistance and it has a voltage source like this. I have made one particular circuit. Okay, suppose this is R1, this is R2, this is R3, and this is E1, this is E2. So how many loops are there? First number thing is that first thing is that we should be uh, able to able to identify how many loops are there. See, what is a loop? A loop is a closed path, okay, so that no other loop traces it. Okay, here you see there is a first I have to label. Whenever I'm getting a circuit, the first step would be to, in the circuit design, yes, okay, the first step would be to, first step if I have to identify any of the circuits, the first step is to label the circuit. Okay, labeling is very important, and labeling will help you. See, suppose you have labeled this as A. Okay, if there is in between any point, okay, the third step is, if there is any element element in between. Some few more people have joined or not, Shruti? You're the alone person.
Yes, sir.
Manoj, are you there?
Yes, sir. How are
Okay.
you?
Now I'm feeling okay. My oxygen levels have come up. Thanks for your prayers and all that thing. And you have made a very good video. I just saw that video. Very nice. This is exactly how I got coronavirus. Okay. I was taking care of mask and all that. If there is any element in between, okay. So if there is, see, now you are seeing element can be, what is an element? Element can be um, resistance. It can be, what is an element? Can be a resistance. Okay. It can be reactance. Reactance can be of two types. That is inductive reactance or capacitive reactance, XL or XC. Okay. So these are the elements that you encounter. Okay. That is your, if you encounter an inductance, so that your inductance L, you will convert it to omega L. That would be your XL. And if you encounter capacitance that will change to omega C. But your XC would be equal to 1 by omega C. Why? Can you tell me why is the reason why it is 1 by omega C? I've already taught you. Hmm? Because if you look at the phasor diagram, okay, look at the phasor like this. Your voltage is always in phase with the resistance. V voltage, supply voltage would be equal to the voltage of the resistance. But the capacitance would be, okay, and inductance would be, see, like this. Okay, VL, if VL is sorry, uh, for VL is like this and VC is like this. So in current it would be ulta. Okay, so what happens is that if this is J, this becomes 1 by J. Because this becomes 1 by J, that is equal to minus J. So you always get this XC in terms of 1 by J omega C. That is the reason it is 1 by omega C. One thing. Okay, now we are, if there is any element in between resistance XL, then label will change. Okay, then label will change. This is not there in your notes. Okay, but I'm giving you in a note form so that you will be able to understand the theory behind it. Then label will change. Now here you have A, I have taken. Okay, there is an element here. Now the label has to change because there is an element. So label will change. Of course, it will become B. Okay. Uh, Now what happens? Okay, in the DC, why have you taken the equation for the series motor, wherein clearly it was written it's a shunt motor? Huh? Most of you have taken equation, and I think all of you have copied. Is it same answers you are getting? Hmm? Are you able to hear? Yeah.
Yes, sir.
Yes, sir.
Yeah, in between, if network goes, na, I'll not be knowing only. Because I'm involved in this, so I can see 12 people have joined. Nice. And we have attendance for this class. Huh? We are having attendance or not? Prateek
We
Kumar is
don't know,
wearing,
sir.
Prateek Kumar is wearing mask in online class itself. Huh?
Yes, sir. Yes.
Okay. You have to be very careful at the home, na, especially you people only. Na, I'll tell you. Saturday 27th, I was there in the lab. So there was Arjun, there was this Madhumita Garjagosh, they all were positive. After that, only after 2 3 days only, you people made me so ill that I had to go to. Actually, for young people, it's not a problem, but those people who are a little bit unhealthy like me, and for them, it's a lot of problem. It creates a lot of havoc. So be careful. Please wear mask so that you don't make others ill. Okay. So if there is any element in between resistance, reactance, then this label will change, of course. Okay. Now you see here, there is a label B. Okay. This label B. Now what happens? There is another element here. Are you able to see? There is an element in between here. Now element is there, so this label again has to change. So this label will become C over here. So again, the element can be a voltage source also. Not only this, it can be a voltage or a current source, anything that is coming except the junction wire. Okay, except the the junction wire. Rest can be anything, can be element. Okay. So here you see this point will become C. Hmm? And there is again an element is coming over here. So again you saw there is an element. Okay. So this point here will become D. Okay. Now you notice here, is there any element? Here you notice there is no element, only the junction wire is there. So once there is junction wire, so this point will be D only. Okay, D only till here. So now you got a circuit A, B, C, D, E. A, B, it is like A, B, A, B, C, D. So this complete loop. Now you have to identify how many loops are there. Can anybody tell me how many loops are there? How many loops?
3, sir.
Yeah, there are three loops. And how many meshes are there? A mesh is a loop which contains another loop. What is a mesh? You A mesh
2, sir.
is a loop that contains, I think only one is there, that contains another loop. So you can say that a mesh is a loop. Mesh is also a loop, but a loop is not a mesh. Okay, so here you see one loop, loop one is like this. Okay, ABD. You can say ABD. ABD Villiers is loop one. Okay, and loop two is BCD. Okay, here you can see this is loop one, and loop two is BCD. This is ABD. Now, if you notice here, hmm, in this particular session, if you are noticing here, there is one more loop, okay, across which you can apply KVL. That is your this loop, okay, the closed path, and that is your A, B, C, D. That is your A, B, C, D. That is your loop tree. Okay. Have you taken it down? So I'll share you this PPT after the class. Okay. Hmm? No problem. So can I reduce a little bit size of it? So you are seeing the circuit diagram. Hmm? Now you tell me here from the circuit diagram if I have to apply KVL, okay, or KCL. Hmm? Now I have to give, see, for current to operate, it moves from higher potential to lower, means it will current will always flow from where it will flow from positive to negative, because positive is high point, negative is low point. What is the reason? What is the reason for this? The reason for this is current takes the path of least resistance. Current takes the path of least resistance. So when it is taking the path of least resistance, okay, I already told you, imagine a water bottle. What is water inside the bottle is like charge, and the movement of charge, that is the rate of change of charge, is current. And by how much distance or by how much height you are pouring it, or how much pressure you are putting it, like you can pressurize the water flow. In If you take one pipe and if you just you want to wash your car, what you do is that you put your fingertip so that water comes with more pressure. So this pressure is called as voltage. Similarly here, if you notice a river will flow from top to bottom. Like if there is a mountain hilly surface, river will not climb that. Instead of that, it will take the path of least resistance, least friction, and it will move in there. Similarly, the current is just like the river flow. You have to imagine the practical scenarios. Okay, don't try to mug things up. So that's why it is flowing from plus to minus. Okay, so whenever in the circuit we are taking any direction of resistance or any other element that is reactance, what we assume is that what is the direction of the current. Okay, so we are giving the direction for resistance and direction of reactance based upon the direction of the current. Now notice here, again I will be drawing this. So three steps you imagine. Okay, the fourth step is, the fourth step is to, step number four would be, have you taken the have you noted this down? Can I move to the next slide? Yeah, can you please help me out? Can I move to the next slide?
Yes, sir.
Yeah, but
Yeah.
it's very difficult. I'm
So
not the same teacher. You can feel the difference in my voice also. I'm not able to shout right now. Please, yeah. So, insert. I thought this PowerPoint is like that hangs a bit. Microsoft. Okay, so this I was trying yesterday here. Yeah, what happened to our previous slide? Okay, what would be our, yeah. So in the scenario, three steps we saw for this particular circuit. Okay, I'll be redrawing this for your convenience. Let me redraw the circuit. We have had a voltage source. Then there is a resistance here, one more resistance. Then I had one more resistance, and here I had a voltage. Here one more resistance, and this resistance was not there. So this is our R1, this is our R2, this is our R3, and there's the one more uh, voltage source. So this was our E1, this was our E2. Now we have to identify. Now if you take this current as I1, okay, first of all what we have to do, label this A, B, C, D. If somebody is comfortable with writing E and F, I have no, like, you can write. But what I take is that so that you understand, okay, it will also, this labeling will also help in understanding whether elements, whether elements like resistance or reactance, resistance or reactance is connected in series or parallel, is connected in series or parallel. So this is one important fact. So now we have to apply here. Okay. So the step number four would be to assume an arbitrary, okay, you need to assume an arbitrary direction of the, assume an arbitrary, very arbitrary means you are pre-assuming, to assume an arbitrary direction of the current. So if you have assumed clockwise like this, I have assumed here, sorry, anti-clockwise, then you assume here also anti-clockwise. Okay, it will be much better. If in the circuit it is mentioned this is clockwise, this is anti, then it's okay. But otherwise, in general, you take one direction. Okay, because this current I1 is getting divided into this and this. If you are taking this direction, it will be very confusing. And to assume an arbitrary direction of the current. Number fifth, a shortcut I'm telling you, which I have already taught you in the class. Now look at this BD. Look at BD. So first, if you apply KCL, KCL, what it states? It states current entering a node is equal to. Yeah, please answer me. What Manoj KCL states?
In a electrical circuit, the incoming current is equals to outgoing current.
Ah, very good. Incoming current is equal to outgo, or you can say current entering is equal to current leaving. Current entering is equal to current leaving. So this KCL everybody knows. Current entering is equal to current leaving. This is the KCL. So let me erase this. Current entering is equal to current leaving. So you just note it down. So here if you see, if I write this as, suppose if I write this as I1, okay, in this circuit, I1. So I1 is entering point V, and if I write this as X, why I'm writing this as X, not as I2 and I3? Because if I have two loops in a circuit like this, I'll have two equations. Okay, if I have one more loop, like if I connect one more loop like this, okay, I'll be having three equations. So the number of loops will give you me the number of current equations. If I write I2 and I3, I'll get confused which are my real loop currents. So this is the loop current. Okay, this you can see, this is the current inside the loop. This again here I2 is the loop current. Okay, and what is this? This is what current? There are, see, there are certain things. This is not the loop current. This is the current in between the loops. Okay, so look at BD, and this is a shortcut I'm telling you. Okay, it will work everywhere, so that circuit theory I have to make easy. Okay, not complicated. What I saw is that when I was teaching in the beginning, I did not give my notes. So, and you had the other notes. So I was teaching, I thought you'll understand, but you require the notes. That is correct, because you are not experts in this field. Look at BD, okay? At BD, if you're looking at BD, what happens is that you're seeing this X value over here. So this, basically this I1 would be equal to X plus I2. So this X is equal to I1 minus I2. Look at BD. In loop 1, X value would be equal to I1 minus I2. If same directions are giving, if you are taking anti-clockwise, okay, and uh, for the same thing in loop 2, X would be equal to I2 minus I1. This I have already taught in the blackboard. Some of you might have missed it. So now this is one thing.
The
Yeah,
current in loop 1 flows from B to D, sir.
the current from, yeah. So here, no, see here you have to see here. This is the direction of the current. So current is going from plus to minus. Okay, here you are seeing minus, here you are seeing plus. Okay, this is the potential. So this would be plus to minus. Okay, here it would be again plus to minus. So this is the direction of the current basically. Hmm. Now uh, here this is plus to minus. Here you see this is plus to minus. So I mean, that means this is plus, this is minus. Again, this has been given. This is voltage, so we have nothing with it. And now this is plus to minus, so this is here for loop 2, this would be plus to minus resistance here. So that's why this change comes. Okay, in loop 2 x would be equal to I2 minus I1. Now if you have to apply KVL, see in each any of your exams, some variation of this circuit is coming. Okay, if you understand the basic principle of this, how to apply this, so you can easily solve any circuit problem. So to learn a problem, you cannot solve 10 problems and mug them, and they slightly change the concept there, and you will not be able to do. So, and it is not that difficult. It is not the like an integral calculus or something is there. It is simple algebra. But most important thing is that what you have to understand is how to apply. Okay. Now suppose here, can you write me the equation in the loop one for KVL equation? Can you write the KVL equation for loop 1? Now what I do is that I consider any rise as positive and fall as negative. So rise is what voltage rising. So if your current direction, see here. Now my concept comes here. Sixth concept is plus and minus. Okay, this is my voltage. If my current direction, this is my current direction. Okay, 6 point would be, this is my voltage, this is my current direction. So if my current direction is moving in the voltage rise direction, then I take it as positive. I positive. Okay, positive means the value of E1 would be positive. Seventh is, if my this is my voltage. If my current direction, this is my current direction like this. If my current direction is in against with the voltage rise, it is dropping like plus to minus, normal direction of the current, how it will flow. Then I will say this as, I will take this as negative, and this would be voltage fall. Voltage fall. See, so like this, I will assume the circuit and I will apply my KVL or KCL. Now, if you look over here, okay. So if you look over here, this circuit E1 current is moving like this because of that. So E1 in this circuit would be positive. Okay. Now here you see it is going down. Okay, it is current is moving from plus to minus. So this would be fall. Current is moving from plus to minus. This would be fall. Can you write me the equation for this circuit one? Hmm? From just looking at this particular point, can you write me the equation? Hmm? Each one of you. Are you understanding today?
Yes, sir.
Hmm? All of you, I'm asking, not one person. Because now whatever feedback you have given, that you have given, now you have to write the examination. So we are least bit bothered about it. We are if you are not understanding, please ask me. Okay, please try to ask. Please, wherever you are feeling any difficulty, or you're feeling that no, it is going above head or something like that, because it's a new subject for you, you can stop me and ask me. So please write me the equation for this KVL for this ABD circuit. This first circuit is there, na? ABD for the loop one. This is
E1 minus I1 R1 minus I
even even
E1
minus
minus I1
I1
R1
okay,
minus I1
uh,
R2.
minus I1 R2 is equal to
0.
uh, yeah, this is correct. Uh, Here this is not I1. This you this value is X.
X.
Huh? This is not I1. I1 is not flowing through R2. What is flowing through R2? X is flowing through R2. And what is the value of X? X value in this circuit would be equal to I1 minus
I2.
I2. Yeah. So you have to be careful. Now can you tell me for loop 2? Hmm? See, electrical engineering means you consider it like a mathematics. When you were studying in 12th mathematics, 10th mathematics, I'll tell you The king of subjects is mathematics. If you believe it or not believe, somebody will say physics, chemistry, but I will not agree with it. It is mathematics. Written the language. God has written the universe in form of mathematics. Everything has been measured and perfected. If sun was little closer to the earth, we will all not survive here. So everything has been put in an order. So mathematics commands the world and the universe. Maybe I may sound philosophical. Similar to this mathematics is electrical engineering. You have to give some time to it, okay, and respect to it. You have to read it like one day before exam, not possible. So that's why there are a lot of backlogs in this subject. Other thing is that if you just give some time, you can score very heavily in this. You can get out of 100, you can get a 95, even you can get 100 out of 100. That in the long run can help you boost your percentage and you can apply for good companies. If in the very beginning, in the first semester only, you score around 80-90%, so your aggregate for your entire course will improve. But if it is going down, then you will be under pressure. Okay, so what I'm telling you this, I'll give you separately notes also, but please concentrate here. Same thing. Okay. So can you tell me for loop two, Tushti? Hmm?
Yes, sir.
Tell me for loop two. Maybe some of you might be seeing it looking what boring thing, but it's a revision class. I'll take some tough problems now. Okay. After in tomorrow's class, some because video will give medium level problems. We'll take video problems and we'll take even tougher problems. Sometimes they can give that also, so that we are prepared for the battle. And if we prepare for the battle, we can win the war. Okay. If we challenge ourselves to a more tougher level, it would be easy. Yeah, tell me for look to Shruti. Yeah, Shruti. Sorry, Srushti.
Yes, sir.
Srushti. Your name is Srushti.
Yes. Yes, sir.
Yeah. Okay. There is a lot of brain fog after you take a lot of oxygen. Na? Then you remove that oxygen and you will get so you forget the names and everything and all that. Okay. Tell me for loop two equation.
I2 R3,
No, no, no. I2 R3. No, see. Yeah, I2 R3. Hmm?
then
No, see. For loop two,
minus E2,
see. I'll tell you one thing. You have to start from here, from X. Loop 2 starts from here, X. So X R2 would be positive or negative. See here, if you look at the loop 2, you have to forget about loop 1. When you are looking at loop 2, you have to, I'll again make it, shall I rub this and make it, yeah, see, because there might be confusion. No? Yeah, for loop 2, if you see for loop 2, here, no? So loop 1, yeah, for For loop 2, the direction of I1 is like this, okay, whereas the direction of I2 is like this, okay. So for loop 2, you have to take this direction of current. This direction of current is always from plus to minus. So whatever this direction of the current is, that will be reflected in resistance. This will become plus to minus, okay. Earlier case, this resistance direction was generated by this current. Now this resistance direction will be generated by this current. So this current is moving and your R2 over here will again be plus to minus. Okay. Now if you see, this is plus to minus, current is also moving in plus to minus. See, this is plus to minus. Okay, and your current is going like this. This is plus to minus, current is going like this. So earlier case, what did you see is that, so herein, can you tell me what is the direction? Everything is, if I'm noticing, everything is fall over here. There is no rise because the direction of the current and this direction is matching. Huh? So everything you can take it as fall. So this here it would be x into, okay, into R2 plus I2 R2 plus E2 is equal to 0, because the sum of all the algebraic sum of all the falls is equal to 0. Here also there is fall, here also there is fall, here also there is fall. Okay, here in E1 there was a rise, okay, then there was fall, then there was fall. Plus to minus was like this, okay. But here if you see, the current direction is going like this, okay, and this current direction only generates this resistance directions. Now you got my point. Now if you put in any circuit like this, you will be able to solve any of the circuits, okay. Whether it is a gate examination, sorry, whether it is a VTO examination or any other examination, you will be able to solve. Now let's take some problem. So this is it. Look at VD, and in loop 1 x would be equal to I1 minus I2. In loop 2 x would be equal to I2 minus I1. Apply KVL in loop 1, apply KVL in loop 2. Step number 6 would be to apply KVL in loop 1, apply KVL in loop 2, and get an algebraic equation and solve those two equations and get the values of I1 and I2. From there you can calculate other values also. Okay. See,
Sir, we
step.
have physics lab class at
Uh,
10:10.
yeah, I'm just winding up. Okay, I'll just wind up this. Okay, so tomorrow I will teach you. Are you understanding Manoj today's class?
Yes, sir.
No, seriously, you tell. If you're not understanding, you tell me. See,
Seriously,
yeah, seriously, because now like we have gone beyond the limits, because now we have to concentrate about your examinations, how it have to happen. Okay, so sixth point would be apply KVL in loop. I'm winding up loop 1 and loop 2. So 7 point, get algebraic equations and solve the values. That is it. These are the 7 steps that you have to apply, and you can solve a problem. So this is basically the first circuit. The sum up of the first module is this only. Okay, in these steps you can get around 20-25 marks. I'll show you tomorrow. We'll solve problems. Many problems we'll solve by applying these steps. After we finish the first module, we'll go to the induction motor, because that module we have not taken in much detail. I became ill after that. We'll solve that induction motor. Then we'll move to the transformer. In transformers, a mistake you have done, all of you, that I have to tell you after seeing your blue books. So I'll wind up this session. I'm sorry to making it for a long time. So I'll wind up. I'll stop recording. And there are 12 people. Okay. So attendance